So here we are. Let's take a look at this ED203, which is a real, this is the full exploit for the buffer overflow, and where you send in some, what is it, quit? Yes. All right. And you send in some real malware to take over the box completely. So, this has already happened. This is ED203. I think I just need to go here. 203. Oh, oops, I got an extra dot in it. There. Okay, so this time we've disabled address space layout randomization, which we've already done, and the program is ed3a, which is already precompiled, so I can cat ed3a.c. All right, again, a nice short program. You have a main program up here. You give it the name of the program and then a string in the command line, and then it exits. If you don't have it, then it goes, so all it does is it prints the stack pointer, and then it runs the copier on the input command line argument, and then it's done. The copier takes whatever came in the input and copies it into a buffer with only room for 1,000 bytes, and then returns. So that's the game here, and the point is, with more than 1,000 characters of input, you can overflow the buffer and take over the machine, but there isn't any code put by the developer here, like the win function last time that you're trying to hit. We're going to inject code within these 1,000 characters and run these characters as if they were code. This is the classic aleph null type buffer overflow exploit. So we're going to have to start with a fuzzer, and I think I've probably got it already made here. Yep, so if I cat fuzzer, all right, here's the fuzzer in Python. All it does is take an argument from the person executing it and put in that many A's. So if I do fuzzer of 1, I get an A, and if I do 100, I get 100 A's. So we can test the program at that. With this, we can run ed3a. If you don't specify the length, put in a string, it tells you to put in a string. If you put in a string, it runs and finishes without crashing. And so if you want to put in variable strings, you do $quote or $parentheses fuzzer 100. That will take the 100 length string and feed it in. And here's 1,000, and 1,000 will work, but 2,000 should cause a crash, and it does. So you can narrow it down a little more. 1,100 causes a crash. 1050 causes a crash. 1040, 1030, 1020. All right, anything much above 1,000 does. All right, so we found that 1020 is good enough to cause a crash, and now we can analyze it in GDB. So use the debugger on ed3a and run with input from the fuzzer of 1020, and it crashes with AAAA in the instruction pointer. So that means somewhere in the last 20 bytes of this, some of those characters ended up in the instruction pointer. That's what I needed to know. So we'll leave the debugger, and now we can locate the extended instruction pointer with this one, EX1. This just prints 1,000 A's and then 4 B's, C's, D's, E's, and F's. So I'll be able to recognize what part of it hit the debugger. So that's EX1. I can run that, and it prints 1,000 A's followed by that pattern of B's and so on. So if I go back into the debugger, yep, I can see what happens. So I go into GDB -Q ed3a, and now I run it with the input from that thing, which was EX1. $EX1 there. Now it crashes with 45, 45, 45, 45. So that's A, B, C, D, E. So the E's are what ended up in the E's right here are what ended up in the instruction pointer. So now I can control the instruction pointer so I can jump somewhere. And what I'm going to do is put an address here that jumps back somewhere here. And I'm going to change some of these A's into exploit code. This is how it works. The classic buffer overflow attack. Now I need to have some exploit code to put there. And you make the shell code with Metasploit. You can install Metasploit on Linux. We've done it before just by running this msf install. And then you'll have msf venom. Yep, I've got it. msf venom is the program that creates attack code. And so you can look for payloads. This is a Linux machine. And I want to have a bind TCP, which will just take a command shell and bind it to a TCP port. That's a simple one. So this one here will bind to TCP, and if you list the options, it will show you that the only thing you need is the listening port, and that has a default value, so you don't actually need to add any parameters at all. So you can run it here. I don't need the sudo on this system. That was just for Google. I can listen on listening port. I can set it to 31337, and I can ask it to write Python code that will do the exploit. That's why this is really very handy. So that will create Python code. This is it, 400 bytes of Python, which is 78 bytes of actual characters. There's the code. And it's different each time for a lot of these. And I found that making an append exit equals true switch makes it better. The other thing, by the way, to notice is this code contains nasty characters like a null byte. And a null byte will terminate the string, so it will not enter. Remember, this is going in as a command line string. So what you want to do is encode it with alpha mixed. That will encode it with nothing but letters and numbers. And append x equals true makes it more reliable. I try these advanced options until I get one that works. So now it's longer. But it's still only 231 bytes. And so it'll fit in the 1,000 bytes I have to work with. So that's EX3. So now what I did was, here's the code that I got from Python, from MSF Venom. Now I add a 500 byte NOP sled in front of it. This is something you very often do. You have a series of NOPs so that if some error occurs in your exploit and the address is not quite what you think it should be, as long as you're within a few hundred of the right value, it will hit the NOPs, and NOPs mean do nothing, no operation, so it does NOP, 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 and gets down to the egg, which is this code, the code that does the attack. So you put some NOP sled before it, and now, so I'm going to have 500 NOPs, then the buffer, and then enough A's to get a total of 1,012. And then down here, I'm going to inject an address that will jump back into the NOP sled. And to find it, I use a dummy one. Let me show you that one. That was EX2. To find that address, here we are. To find that address, I put in everything with my buffer and the A's, and then I just put 1, 2, 3, 4 here. And now I run this in the debugger. So gdb-q ed3a, and I want to run that one. It's called ex2. So run. First I have to find a breakpoint, so I disassemble copier. Okay, here's the copier function in assembly code. Here's the string copy that causes the overflow, and here's the return that makes it crash. So I want to break after this copy, but before it comes back. So this copier plus 48 would do. Break star copier plus 48. All right, now I can run it with ex2. It'll hit the breakpoint. Now I can look at the stack. If I open the registers, the stack goes from CCE0 to D0D8. I just have to remember the D0D8. Now I 440X ESP. And I'm looking for D0DH. So I have to press enter a few times. Okay, here is D0DH. There you go. That's where the A's went. Here's where the 1, 2, 3, 4 is. And I need to choose a better value to put there. So I go back up here, and you see here's the NOP sled, 90, 90, 90, 90. And here's the actual attack. So all I have to do is pick any address inside the NOP sled, like this one, for example. So I'll just copy that. If I jump to that location, then it will run through the NOPs and execute the exploit. So I'm going to quit out of the debugger. And then cat ex3 is the next one. And what I put in my clipboard was FFFFCDA0. And you see that's what I did here. FFFFCD. I used E0. I just made a different choice. But that's how I got this number. This is now an address that points back to the NOPs before this buffer. So it will run. So that's the EX3. We done all this. That completes the exploit code. And so now you should be able to run it. So if I do GDB minus Q ED3A again, and I run it, taking the input from EX3, it runs and it doesn't ever come back because now it's listening. Now if I go to my other shell into the same box here, I can now do sudo ss minus pant, for example. This will show the listening processes on the machine, and I should have one listening on 31337. So ED3A is listening on that port. That's the malware, and I can connect to it on the same box. Loopback will do. And now I get a shell. I can do ID, who am I, uname minus A to see what version of Linux is, and so on. This is now the malware running, giving me a listening shell. So that's the whole process of a normal buffer overflow exploit, where you inject code and you run that that code. And that's what I wanted to show you. So I'll stop this one.